Hello everyone, in this video I'll be demonstrating how quick and easy it is to set up and program our Panasonic A5 servo drive using our Real-Time Express servo control network. I'll be setting up a 2-drive demo utilizing our FP Sigma PLC and its expansion module for the RTEX controller. Now I'm going to snap those two side by side and lock them together using these blue tabs, and that'll allow me to put it onto a DIN rail. Now I will put in the power cable. And now I'm ready to do my network connection. Now it's a very simple ring topology. I'll use the transmit of the PLC and I'll put that to the receive of the first drive, and then the transmit of the first drive and do that to the receive of the second drive. And then lastly I will take the transmit of the second drive and put it to the receive of the PLC. So the only thing left to do on the network side of things is to address the two motors. I will put the first one as 1, and I will put the second one as 2. Okay, so now we're ready to hook up everything else, which is just putting in our motors. So I will first put the power connections. Now the power connection itself has a ground wire that needs to be hooked up, so let me do that right now. Okay, and I'll do that now for the second one as well. Now there's also an encoder cable. Plug those two in. Now I just need to snap everything together on my motor side. And last but not least, I will power up each controller. And I have to put a programming cable into the FP Sigma PLC, and that I will connect to my computer. Okay, so now turning on power to everything. Everything looks good. So let's hop into our FP Win software and see what we need to do to get this up off the ground. Okay, now that we're in our FP Win Pro software, we're going to begin by selecting New Project. That'll bring up our Creation Wizard. We'll select our PLC type. In this case, it's an FP Sigma 32K. And then I'm going to name the program RTEX. And make sure that ladder diagram is selected and click Create Project. Now, the first thing we need to do is import the library for our Real-Time Express. I'll do that by right-clicking on Libraries, going to Library and click Install Create. Now I'll be able to navigate to the path on my hard drive where that library exists. I'll double-click on it and hit OK. Now that's going to import all of the library function blocks that we have for Real-Time Express. Okay, now double-clicking on my program, I'm now ready to start my project. The first thing I'm going to do is I'm going to turn on both of my servos. So I need a servo on-off function block for that to happen. On the right-hand side, you'll see instructions. Now I can either specifically find the function that I'm looking for, or I can just start typing it in, and it will navigate directly to it for me. So clicking on, or typing in RTEX_SER brings my servo functions. I'm going to double-click on servo on-off, and I'm going to drop that in my first network. So in order to turn it on, I want to use a contact. So click Contact, and I'll drop that next to it. I'm going to name it Servo On Off. Click Create to declare it. Now I need to connect that to my Servo On input. So double-clicking anywhere on the screen brings up my pen tool. So I can click and drag my way over to my Servo On input. I'm going to do the same thing for my off, but I'm also going to say servo on off. I want them to be the same name. Now this one I want to be normally closed, so I'm going to double click on that and click negation and then OK. Now once again I have to connect them over, so I'll click and drag my way over to servo off. Now the last thing I need to do for this function is to tell it which slot number I'm working in and which axis I want to reference. So the slot number is the position where the RTEX expansion module is in relation to the CPU. The first slot to the left of the CPU is 0, and that's where this is, so I'm going to click 0. Axis, I'm going to select 1 for the first axis. And everything on the right-hand side I do not need, so I'm going to highlight it all and hit delete. Now I want to do this again for my second motor, so I'm going to right-click on the first network, hit copy, right-click on the second network, click paste, and the only thing I need to do is change my axis to 2. Okay, so now we're ready to program our actual motion. We're going to do that with a function block that does incremental or absolute motion. So clicking on instructions, it's again RTEX_INC, and that brings it right up. So double click on that. I'm going to throw that in my third network, and I'm going to name it axis 1. Click create. Okay, so I'm going to drop a contact in here to start that motion. I'm going to name it start axis 1. Click create, and I want that to be a rising edge, so double clicking again on the contact, I'll click rising edge and OK. So I need to connect that over. Didn't quite get there. Alright, so now I'm going to do another one. I'll explain this and why I'm doing this in a second, but I'm going to name it restart. And I once again want it to be rising edge, and then I'll connect them together in an OR configuration. So either start axis 1 or restart will start the motion on axis 1. Okay, so now everything else is in my parameters, so I'm going to delete stop. I don't need that. The first parameter here is whether or not we're selecting this function block as an absolute motion or incremental motion. I want this to be incremental. So the parameter for that is 0. If it were absolute, it would be 1. Now the speed is in pulses per second. I'm going to set this at 1 million. So that's going to be about 1 revolution per second. Acceleration time, I'm going to do 200 milliseconds. Deceleration time, also 200 milliseconds. My travel, I'm going to do 1,000 or 1 million pulses. That's going to give me right about 1 revolution. It's a little less than 1 revolution, but we're going to round off for simplicity's sake. And then once again, I got to tell it which axis we're working on and what slot we're in. Okay, so on the output side, I'm going to do something different here now. I'm going to use axis 1 done as my name. I'm going to create that. So what that'll do is once this is done rotating, it's going to activate that. Busy I do not need, so I'm going to delete that. And then for visual sake, I'm going to create a name axis 1 position, and that will update with the position of the motor as it's going. So once we start this moving, you're going to see that increment and you'll be able to monitor it visually. Okay, so we got our motion done for our first axis. We need to do this again for the second. So I'm going to copy and I'm going to paste it into my fourth network. Okay, now I'm going to change this to axis 2 for our second motor. Okay, I do not need my restart now. So I'm going to delete that out. I'm going to delete the lines as well. Okay, now my axis number is now 2. And I want this to start when the first axis is done completing its rotation. So I'm going to change that to axis 1 done. So the logic is now the start axis is going to start this motion. It'll do about 1 turn. Once that's done, it'll start this one, which will do about 1 turn. Now for the done side here, I'm going to now put this as restart. And I'll do that because I want this to alternate back and forth. So now once this is done with its rotation, it'll activate the restart, which then in turn activates the first axis motion again. So it'll just go back and forth indefinitely until I shut it off. So this is basically what I wanted to show, so I'm all finished. The only thing I need to do left is to go online and compile this and put it onto my PLC itself. So I'm going to click online mode. And now I'm going to click download program code. So as long as I didn't make any mistakes, it will compile and it will upload that to my PLC. Okay, so now that we have our PLC program code written, let's go back to our setup and see this in action. Okay, now that we've gone online and downloaded our program code to our PLC, we're now ready to start the motors and start our rotation. So what I'm going to do first is I'm going to double click on our on signal for the servo on-off variable, and once I do that, both of these servos will turn on simultaneously. Now from here, all I need to do is begin our motion, and I'm going to do that by double clicking on our start axis 1 input, and that will begin the rotation for axis 1, which will in turn start the rotations for axis 2, and so on and so forth. So let's do that right now. Okay, now you can see the motors spinning, alternating between each other, but what you can also see is on the FPWin Pro side, the axis 1 position and axis 2 position outputs are incrementing as they are rotating. So you get an idea of what's going on with the motion itself. So from start to finish, this took us about 10 minutes or so. So hopefully that'll speed along your motion processes and make it a lot easier for you. If you have any questions, please give us a call or visit our website at pewa.panasonic.com.